Markerless navigation system for anterior cruciate ligament reconstruction with 3D femoral analysis and arthroscopic guidance. Anterior cruciate ligament reconstruction success hinges on precise tunnel placement, yet traditional arthroscopy leads to non-anatomic positioning in up to 30% of cases due to poor spatial orientation and limited visibility. While existing navigation systems could help, they require additional markers, disrupt surgical workflow, and involve time-consuming processing, creating a clear need for a more efficient, minimally invasive solution. Our anterior cruciate ligament navigation system integrates two parallel modules working seamlessly together. The 3D femoral analysis module reconstructs patient-specific models and calculates optimal tunnel positions using automatic landmark detection and Bernard and Hurdle grid mapping. Meanwhile, the arthroscopic guidance module processes live video using SIFT-ICP registration to provide augmented reality guidance. This markerless approach delivers precise intraoperative navigation without disrupting standard surgical workflow. Our system reconstructs the 3D femoral model from CT images and establishes the initial sagittal plane using key anatomical landmarks. We then perform geometric analysis of the condylar profiles using curvature calculations and elliptical fitting to characterize their morphology. Through an iterative optimization process that minimizes eccentricity and focal dispersion, we refine the sagittal plane orientation, preserving the lateral condyle, which contains critical landmarks for precise anterior cruciate ligament tunnel positioning. Our approach extracts critical feature curves from the lateral femoral condyle through a two-step process. First, we perform principal curvature analysis on the 3D mesh to identify high curvature regions, connecting these points into continuous curves. We then refine these curves through anatomical filtering to isolate the clinically relevant characteristic lateral ridge. Using Blumensatz's line as reference, we establish the Bernard and Hurdle grid system on the lateral condyle. A video capture system was integrated with the arthroscopic equipment to enable real-time visualization and recording. The system comprises a compatible video capture card connected to the arthroscope's output and computing device, configured with appropriate drivers and software to optimize image quality parameters. Our system overlays a Bernard and Hurdle grid onto arthroscopic images in real time, enabling precise ACL tunnel positioning. Using a SIFT-ICP registration framework with sub-millimeter accuracy, the semi-transparent grid maintains visibility of underlying anatomy while providing standardized references. The system dynamically tracks key landmarks like Blumensatz's line, allowing surgeons to accurately locate optimal tunnel entry points within their familiar arthroscopic view. This figure demonstrates our surgical navigation system for tunnel positioning during ACL reconstruction. By overlaying the Bernard and Hurdle grid onto arthroscopic images, we transform standard arthroscopic views into precise surgical navigation tools. The grid system provides standardized anatomical references that guide optimal femoral tunnel placement, allowing surgeons to identify the ideal entry point with greater accuracy and confidence. To validate tunnel positioning accuracy, we compared expert clinical judgment with computer-assisted navigation guidance. An experienced surgeon marked reference points on the femoral condyle using radiofrequency ablation, which were then compared with system-recommended tunnel locations. Among 7 groups evaluated, 43% achieved excellent concordance, 29% showed acceptable results, and 29% needed improvement. Our system demonstrates significant potential for enhancing femoral tunnel placement precision in ACL reconstruction. The system maintains standard surgical workflow while enhancing visualization through grid overlay. While performance depends on image quality and larger clinical trials are needed, we've successfully integrated 3D femoral modeling with real-time arthroscopic guidance, allowing over 70% of expert users to achieve superior accuracy levels.